Hello everybody! Today we're going to look at an arithmetic progression problem. Alright, so given an AP, an arithmetic progression, where the pth term is equal to a value of q, and given that the qth term has a value of p, and obviously p and q are integers, the question is, what is the p plus qth term? Alright, so if you want to give this a try, feel free to pause the video, and when you're ready for the answer, click play again and we'll be rating right here. Alright. Okay, welcome back. So I hope you've had a chance to give this a try. So just to recap, the question was, given an arithmetic progression where you have the pth term equal to a value of q, the qth term equal to a value of p. Okay, what is the p plus qth term? So let me just give you an example. So maybe you're given that the fifth term is equal to, I don't know, 7. Okay, maybe. And given that the seventh term is equal to 5, what's the 12th term? All right, so that's kind of how the question is structured. So there's a bunch of ways of doing this. Okay, the traditional way, which is the non, out of the box way of doing it, is to express your pth and qth terms in terms of your standard arithmetic progression formula. So TP is equal to the starting term a plus p minus 1 into the common difference, right? So this is pretty standard. I'm sure you've learned this in school. And of course, given that TQ, well, that is equal to Q. That was the first statement right there. And given that the Qth term, which is obviously that, is equal to P, how would you solve for P plus Q, which is A plus P plus Q minus 1D. Okay, what is that equal to? Okay. So obviously you've got two simultaneous equations, you've got two unknowns, A and D. You try and solve it by subtracting and so on. Okay, it might get a little bit hairy. So today, we're going to introduce you to a different way of looking at arithmetic progressions, okay, which is to think of them as coordinates on a Cartesian plane, right? So this is what I mean. If you have, for example, if you plot, say a simple xy coordinate system where your x-axis essentially is the nth term, and your y-axis is tn. So you might say your first term, which is t1, of course is equal to a. That's your standard arithmetic progression definition. So that is a. So you might represent your first term as a coordinate 1, a. Your second term is a plus a certain common difference, so it's maybe a plus d over here. So that's represented by the coordinate 2, a plus d, which is that coordinate right there. Okay. The third term is 3, a plus 2d, right, which is right there, a plus 2d, right, and so on and so on. So it's obvious when you plot this, this is going to turn out to be a straight line. Okay, and I'm sure you've learned from your basic geometry that a straight line can always be expressed in the form of y equals mx plus c, right? So that's your y, that's your x. Y equals mx plus c, where c is a constant. All right, you can rewrite that, but you don't really have to. Okay. Tn is equals to some slope times your n plus c. Okay, I'm just going to stick with y equals mx plus c for now, okay, just to keep things simple. Now, how do we apply that formula to this? So let's have a look. Alright, so let's see if we can apply this coordinate geometry approach to solve our problem. Right, so if we have the pth term equals to q, okay, we could rewrite that in a coordinate form by putting p term and the value of q. Alright, similarly, the qth term equal to p, that can be rewritten as a point q and p. So now you've suddenly got 2 points on your straight line, and that is enough to actually plot a straight line. So if that was p and your q term, well, that might be q, right? And notice I've just drawn q here to be a bit large, right? So if you've got the value of q down here, okay, we're telling ourselves that it's got a value of p, right? That's your second point right there. So that forms a straight line. Okay. So the trick to answering this puzzle, of course, the question was, what is the p plus q term, right? So the trick to answering this question is to find out the expression for this straight line, right? And then substituting the value of p plus q, okay, into x. So how do you do that? Given that you've got 2 coordinates like this, can you find an expression that links x and y, right? You've got to express y in terms of x. Okay, there's a couple of ways of doing this. I think if you've learned basic geometry, you can take this, the first coordinate, subtract it from the second, and form a gradient and so on. But you can tell from inspection that whatever value you have in your x and y coordinate added together gives you a sum of q, right? So in this case, the straight line is really x plus y, the sum of the 2 coordinates, is equal to p plus q. Right? If you rearrange this, I mean, that gives you y equals negative x plus p plus q. So minus 1 is your gradient, and as you can tell from our little sketch here, the gradient is actually negative. Right? And p plus q is your y-axis intercept, which if you extend that, that would actually intercept your y-axis at a value of p plus q. Excuse my drawing right there. Okay, so the question now is, for the p plus q term, right, you would substitute p plus q into here. What would y be? Right. Minus p plus q plus p plus q, that obviously is equals to 0. So it turns out that your p plus q term is actually equal to 0. And that's your answer right there. It's equal to 0. Right, so that's just a very simple way of solving the equation. I hope that's something that you can use in your exercises. Just as a recap, you might want to have a look at the traditional way, okay, of solving the problem, just to show you, how much easier this method is. So if you rewrite your problem statement this way, that's equal to q minus 1d, that's equal to p, right? You could subtract one from the other, and you'd get p minus q into d is equals to q minus p, and therefore d is equals to negative 1. Right? You could also then substitute d back into here, and you'll find a plus p minus 1 into negative 1 is equals to q. And if you solve for that, you'll get a is equals to p plus q. Is that right? Hope I got that right. Not sure that I did. Sorry about that. Let me see. That's negative p. There is a negative 1 plus 1. That's minus 1. right? So if you substitute all of that into your problem statement, the question is, what is TP plus Q? That would be A plus P plus Q minus 1 into P plus, sorry, hang on. Sorry, I messed it up. So that's equal to A into P plus Q minus 1 into D. So substituting your values of A and D in here, that gives you P plus Q minus 1 plus P plus Q minus 1 into negative 1, and that obviously is equal to 0. Right, so it's a little bit messy. You've got to take care of your negative signs, and you've got to be really careful about your multiplications. So the coordinate geometry method is just a really quick way to visualize what you're doing, and that way you can make sure you don't make any careless mistakes under pressure of your exams. All right, so I hope that novel approach to looking at arithmetic progressions will help you. And thanks for watching. I hope to see you in the next video.